Okay. Hello, good evening. Right. Let me quickly set things up. Blah, blah, blah. Hope the volume is gonna be fine. Alright. Welcome to another episode of things.
Welcome.
This is the future. The world as we know it is gone. Acid rain has left the land barren and the water toxic. Scarred by endless wars, humanity struggles to survive in the ruins of the old world. Frozen in everlasting nuclear winter. This is the future. This is the year 1997.
Okay. Sorry. People were,
Troubleshooting. Nice.
Yeah, people were, doing things. Anyway, so yesterday, I implemented a sort of a parser for our dialogue markup language, or at least I extended markless to handle that kind of stuff. And earlier today, I went back and factored things around so that it's a bit nicer, more nicely laid out, and I also improved some stuff. For instance, I improved how the conditional is handled so that in the syntax tree it's actually now properly structured rather than being sort of flattened and spilt into the surrounding context. So everything should be set up from the syntax parsing side. So now we have a complete AST, and we can start worrying about how to actually compile this AST into something that can be, well, executed in some sense. So that's what we're gonna do today. Just to show real quick though, let's see, all right. Syntax parser. Just to show that the conditional things work fine. Foo. Bar. Bar. Whoa. Baz. Where was the thing? There we go. Yep. It is a Gamedev stream. What are you talking about? It's just not going to be visual, but it is going to be Gamedev. Okay. So, yeah. So it parses the conditional into a proper kind of structure that we can make use of. Alright. I also went back and went into the specification. Where is it? And wrote some stuff about how things should be executed, which is fairly, self-explanatory. It's nothing great or anything that we would not expect. So the bigger question is now, how do we take, an AST like this and turn this into something that can be executed? Now, this is not going to work as a traditional kind of compiler for a programming language that can just, execute statements one by one and then return. We could do it like that, I suppose. The problem is more that the way it's more intuitive to use would be that you have some kind of interface that you call with a current kind of state, and then it returns you the next action that should be done. So, for instance, display this text, or wait for user input, or display these choices, or whatever. And then you, once you know, you've handled that kind of input or output, you call the function again to advance the state. So it's more like a state machine that you have to explicitly advance. Or in the very least, that's my thoughts right now on how this should work. Right. Yeah. So, right, the question is going to be how are we going to get that done? Especially, I guess if we start from something very simple, so let's have a look at something simple. Let's do this in fundamental mode. So let's say we have markup that's like, I don't know, just some text. So when that is sort of executed, all that should happen is that the text box displays this string up here. And typically, when things are executed, they always execute up until to a point where user input is needed. So you would have some number of text parts, and then you would have a line break, which requires a text scroll to happen. So at that point, the execution of the dialogue needs to stop and return control to the game in order to, you know, allow it to do stuff. So what we could do, I guess, is to gather all the text that should be displayed until some kind of user interaction is needed, and then return the text that should be displayed plus the user interaction that should be done to get to the next state once you call it again. So I think that might work. The problem with that kind of is how do we, you know, deal with other stuff that happens, like any kind of forms that need to be evaluated, or kind of game state changes that should happen as part of the dialogue execution. And for that, I'm not entirely sure. They could be added as another return value, but then it kind of gets muddy because what qualifies as a change in what sense. So I'm not too sure. They could also just be literally evaluated by the system when you call, you know, the step function, which I think could be better, question mark? I don't know. Indeed. So as an example, again, to sort of illustrate the two choices that I'm thinking about right now, let's say we have this, and then maybe we have an emote kind of thing, which was happy or whatever, and then maybe, actually, yeah, one of the two isn't even going to work, never mind, because of conditionals that need to be done. But other kinds of things could be delegated. So, for instance, if you had set of bar or something like this, then the, you know, the return value of that would have to be just some text, and then, you know, you could either have the state change of happy happen automatically and of set a foobar, or return that as some kind of value that should be executed. So you would have to have a list of things that need to be validated, forms. So you have that, and then maybe or something. And then you would have what kind of interaction is needed, which is continue, you know. But that's not going to work because if you have something like a conditional block, you know, that says, you know, happy p or whatever, then this or that, then we can't return all the text that should be displayed. So we can't, you know, do that. So the evaluation of this form in here, which can be arbitrary code, has to be done before things are returned. I mean, I suppose I could just, you know, do that still, but then it will get really, really complicated. We would essentially just transform it into yet another AST that needs to be somehow evaluated and concatenated and whatever. And that doesn't seem useful or worth it. It would just be yet another representation of the program flow. Right, so the other choice is to simply have two return values. The thing that's executed, that should be shown, and the user interaction that's needed. And then you could have a third thing, which is just the user interaction that's needed. And the text display is also handled by the execution. Now that I don't like as much. The reason being that in the latter case, the system that it executes this dialog actually needs to know something about how text is displayed and all kinds of things, which are parts of the other system that needs to handle the user interaction. So there's an inverse flow of information, which makes the system less general. Or you would need some kind of API in order to hook that in, or like provide some kind of callback to handle that. And that seems much more annoying to me than if you simply return the text that should be displayed and a continue. Hello Finn, good evening. Now the problem with this approach versus this approach is if you do something like actually, is there even... Let me look at the spec real quick. Well, I guess I suppose we can do it anyway, but it's if you do something like where you have some text and then you have an inline thing that changes how the text is handled, so maybe something like setf text speed 2 and then other text, and you would expect some text to be normal and then other text to be faster. That would no longer be the case in this, because it would just return some text, other text, and the speed change would have already happened at that point. And so all of the text will be displayed with text speed 2. So this sort of performs an implicit reordering of stuff. Why can I not? What is happening? Why is Emacs froze? Great. Yeah. But I'm not sure if that's really a problem at all. It should only be a problem if you have inline forms that alter state, which you shouldn't do, because the only things that are inline are sort of predicates. And also if you expect that alteration of state to affect the output of the rest of the same line. If you have multiple lines with statements in between, then you're going to be fine, because those require going through the confirmation anyway. So, or going through a return anyway. So I think this is actually a fine idea on how to handle this. Okay. So in specific, our parser needs to function in a way where it's it has some kind of state that's passed in that, and that state identifies where we are in the current execution flow. So state identifying, or well, it's, you know, it's kind of a like a what is it called, the instruction pointer, I guess. Whoops, not that much. So we need to have an instruction pointer, and then when we execute by start from instruction pointer when encountering strings, append string to buffer. When encountering new line, return with buffer and continue. When encountering component, recurse into component. Right, and the actual component behavior is typically just do some stuff, and then if you have child elements, iterate over the children in that. So basically, you know, repeat this procedure, but recursively. Now, one of the problems that happens when you do this recursive kind of thing, the instruction pointer gets complicated, because you're now no longer just pointing at a certain index in a flat list, but rather you might be pointing into somewhere deeply nested, which is much more complicated to look at. So the first thing that we might want to do is to do a pre-process where we transform the AST into something that's entirely linear. And by entirely linear, I mean that if you have a let's get an example. So foo bar, and then you might have a choice A, B. Let's actually make this into markless mode. There we go. Not sure why these aren't marked up. That's nice. Thank you, Emacs. Great. Okay. So you might have a choice of choice A, and you might have choice B. And if you choose A, you can have another choice. And you might have choice X and feck. Actually, let's do peck. There we go. You know. And then you might have ramification for this, foo. So in this sense, you can have nesting in the execution flow, and we can linearize this by instead doing a transformation where we do something like this. So we do let's call this G1, and then we have a label G1, right? And then we have another choice which goes to G2, and then we have a label G2, foo. So in this way, the execution state is always linearized. So there's never a point where you have to point into something, but rather you always have an instruction pointer which points here, and then once you go here, you have to evaluate this. We have an instruction pointer pointing here, and then you have to go into, you know, G3 or whatever. We have a pointer pointing here, and it knows it has to be inside a thingy. You know. Right. There is some nesting still in this case. At least in the way we have represented this right now with the AST. Mostly because this block quote contains a paragraph which contains lines. So that's not so nice. So we might want to have an alternate representation, so a secondary AST anyway, or in this case more like a an intermediate representation. That will be the proper name for it, which has a different kind of structure. So if I undo that, hold on. Choice. Let's just outline this. Let's try this. Okay. So if this is our source text, we might want to transform this into something that what was the there we go. That looks more like this. I'll use Lisp syntax because that's more useful. Source foo line r. I'm not gonna retype that. Choice. Choose. And then we have not choose. Choice A. And then we have a label for that, you know. And then we have, actually, in this case, we can always linearize it pretty easily, I think. So we add choose. Let's copy that. And B. Oops. This is actually wrong what I'm writing right now. Whoops. So it should be something more like wait. Let's also name this something different. And then we have C1 is C3. Not sure why I made a colon here. You know, so this would be sort of a linearized output of transforming this. This is basically what we want to compile down to. For lack of a better way of doing this, I denoted it like this. Actually, I can do that better. Let me see. Let's make a new buffer here, paste that in there. And instead of doing that, we choose 5. C2 is 9, C3 is 6, and C4 is 7. So now, when you have a choice, or when you ask the user to choose, when you have a choose instruction, it has a label of, you know, describing what should be chosen between, and then you have each choice associated with a pointer number, which points to the line where we should execute if that choice is taken. Similarly, so these would be sort of the equivalent of Go instructions. Similarly, we can transform Go end into a Go of 10, which is outside of the scope, ending the execution immediately. So using this, we have now turned this into a sort of an assembly language where you have just an instruction pointer pointing to where we want to go, and then we just execute one statement after the other until we hit something that should well, actually in this case each line will always immediately terminate, which might not be, or not terminate but suspend, which might not always be the case, so this is kind of a bad example. Let's say, let's add a thing here, which might be like setup scene thing, I guess. So you would have a in here, and so it would actually evaluate this and then go on to the next one before returning. So when control flow sort of exits this execution context,
I'm not
is
sure
not
about jumping to line numbers in the instruction list. It would make small edits painful, no?
But this is the compiled output. So we write this. This is actually the syntax that we implemented. So this is transformed into an AST, and we're now talking about a compiler that will transform the AST into something like this that can be executed both efficiently and conveniently. So I can actually, you know, take this here and put it in here, and it'll parse it into an AST. So this is the AST that's parsed from this markup here, and we want to turn this AST into something like this so it can be evaluated easily. Right. So another problem with this right now, as it is right now, is that, for instance, let's say we that is not right because we not changed the line numbers. Yeah. Annoying, huh? Oh boy. 10, so we need to just... Right. Thanks for the question though, really. I know I can go a bit too fast a lot of the time, so I appreciate it when you sort of, you know, keep me back a bit so I can go back and explain things more detailed and more in a more understandable manner. Okay. Anyway, so a problem with how it is right now, which is a sort of a very literal kind of translation, is that, for instance, if we choose 6, then we go to choose this, which is fine. But if we choose X, it's going to go to line 7, but then it's also immediately going to go to line 8 and then line 9 because it doesn't know any better. So what this compiler needs to do in addition is also insert Go statements that'll jump outside of the scope that we sort of established, which is annoying. So we need to have for convenience, let's go back into labels instead of, you know, strict line numbers. C4. So this is going to be C1. It's going to be C3. C4. C2. Right. So what we need to do in addition to this is, if we exit the choice A, then we need to continue.
Might want to split choose into present choice and enact choice so the execution can be suspended while waiting for some other subsystem.
Yes, so that was the idea. So if there is a string to be displayed like a line, then it remembers the current instruction pointer or the next instruction pointer, and it returns execution to, or it returns outside of the system so that the string can actually be displayed. Or in the case of a choose, it'll return the choices and the label sort of for it, and then the system will call back into it saying, okay, this was the choice made, here's the new instruction pointer where we want to continue. So that's, you know, that's the idea of handling this in a system where you want to do everything synchronously but very quickly. Does that am I right in assuming that my thought process is the same as yours? Or am I not understanding you correctly? Yeah, so this is trash down here now. While I wait for a response, quickly. So right, the way it is right now, if we jump to C4, or if we jump to C3, we're going to sort of spill out into C4 instead, which is not what we want. So what we need to do is for each choice where we sort of flatten out the labels.
On how exactly the dialogue system interfaces with other systems.
My idea for this was that in the end, what you actually do from the game engine out is you call something like, you know, step dialogue, and you pass it in an instruction pointer, and then it returns from there something like this, a string to display, and what it should do. So either like wait, or it could say and choose, let's standardize that. Choose between X, which would take the IP to 12, and here we would have it to, like, I don't know, 10, or Y, which would take it to 15, or whatever. So after calling step dialog, the game engine takes care of displaying this, and in this case displaying a choice. Once the user continues or has made a choice, it passes the new instruction pointer back into step dialog to get the next thing. And this sort of continues until it, I guess, returns nil. In which case it ends, or it could do that, and, you know, to normalize it, I guess. Does that make sense? Anyway, right, so in order to make this properly, we need to guard each choice with another tag. So we would have C5 here, I guess, which would do nothing. And we would have another one for the inner choice, which goes after this one, 6. No, wait, yeah, no, wait, never mind. That's actually, no. The end of each choice needs to be a C5, and here also goes C5, and here choice X needs to go.
Yes, if you have this powerful choose return value, it should work.
Right. And here it goes, C6. Whoops. Okay, so now the way it is right now, it should work fine. Yeah. Yeah, the reason why I want it like this is because I want to entirely decouple anything that's displayed to the user from how the system functions. So anything about how the actual engine works should not be a part of this dialog system. This will be handled by, you know, things the user supplies, which are everything surrounding step dialog, and like whichever package these forms are read and evaluated in. Yeah. So now that we added in these extra labels and these extra jump statements, we should be fine. So let's try this out again. We take the source as food, and we have a bar line which goes into a, you know, returns bar and weight, and it returns 3, and then 3 comes and it setfs the thing, 4 comes, it returns this whatever it is, and 5. So then it continues again, 5 comes, it returns the choose string and a choose list, which is encompassed of these things, these choices here, at which point the user might choose A, and then it jumps to C1, which we currently haven't translated into line numbers. So that goes here, again, same happens. And now if we choose make choice X, we go to C3, that displays foo, which goes to C6 afterwards, once that's continued. C6 is here, which goes to C5 immediately, C5 is here, and then we're at the end, and we're done. So that will be the equivalent of choosing A, choosing X, displays foo, and we're done. So doing it like this is actually how assembly works, kind of, sans the returning execution state. This is how assembly transformations are done from source code. So we are going to write a sort of a form of an assembler, I guess, and a form of an assembly language as well. Okay. And I think that's actually everything, because the system, all it can do is display text or
Time
display
to rewrite
choice.
Leaf completely in this.
No, that wouldn't work. Actually, hold the fort. That's not going to work. It's not going to be enough. The reason being that subsequences of the text might be like marked up with bold or a color or some kind. So we need an additional return value that also informs us about which sections of the string should be marked up in which manner. So we would have like another thing that says characters 0 to 3 are color head, I guess, and characters 3 to 4 are blinking or something. I don't know. So we need another return value that tells us the markup of the text. Yeah. Okay. Right. Is there anything else I'm missing? No. That should be fine. Okay, so how are we going to handle this transform stuff? That is now the big question. Big dollar. Whoops, not like this. Back. There we go. Or actually I should probably do it like this. Keep pressing wrong buttons. Terrible. Okay. Yeah. Well, first thing we definitely need is some way of traversing the AST. So we're gonna do a def generic traverse AST function, or let's just call it walk. Yeah. Okay. That should be the first easy thing to do. Well, actually, we should probably call. Should we call it on the thing itself? Probably not. Maybe. I guess we should. Do that as a before. Do we even need this at all? Do we need a function? No. I mean, we can encompass the actual semantics directly in the walk function itself. So we want an AST and some kind of output thingy to hold. Though we could also just do that as a dynamic variable, I guess. I'm thinking. Okay. When we encounter a string, we just want to append it to the current buffer. So let's define a class. Let's put, I guess, or
See what the rest of the wasteland looks like.
let's call it assembly.
Well, there's not much.
And this is gonna have a
I know.
actually hold on. I'm thinking I'm thinking. Do this easily. Or not easily, but in a well-designed manner. Should have thought about this stuff a bit more ahead of time. But I guess hot in the water, huh? Or what is the expression? I don't remember.
Me neither.
So I'm trying to think. My idea right now is to, when we encounter a string in the source AST, then we either need to start a new line. No, is that always the case? Kind of. Not really. This is still going to get a bit more complicated than it appears right now. For instance, if we had choice B being conditionalized, so if we had a thing like, I don't know, whatever, you know, then in this case, the choice is actually going to be behind something that needs to be evaluated. So the AST can't look this simplistic, or the assembly, I guess. Whatever we want to call it. So in this case, it would have to look different. It would have to be something like F whatever. C2. Can I always transform it into something like that? I think I can. It's also not going to be quite that easy, so this is going to be essentially choose is going to be because you know, this might also have inline directives. So whenever a choose is encountered, it needs to actually evaluate all of its choices because they might have conditional parts in it as well. I'm also trying to think about how that would happen. Because again, this could also have a conditional in it, like whatever, man. Predicate 0. So what this text is also dependent on the execution, which also means that the string can't always already be fully assembled. So we would need some kind of like choice B and then something like that. Yeah, and if things are ever broken up for whatever reason, you might have multiple whatever here. The compiler could compile these together. I guess it could always assemble these together before it returns in the very least, because at that point it is known. This is also going to make things for markup really, really annoying though. Because imagine we have, you know, instead of 0 and 1, which are both the same length, you might have something like this, or in here, and you might have that both bolded. You know, in which case the markup that's presented, this is not just for a choice label, but in general needs to be able to adapt to whatever this is going to evaluate to. So this could either be, you know, index 9 to 12 or 9 to 10 for the bold markup, I guess. This is getting complicated. This is getting complicated. Oh boy. It gets even more complicated when you consider the possibility of runtime splices. So if you have, you know, something based on a variable that's spliced in. So in this case it would be, you know, where. So in that case, where the boundaries are is fully runtime dependent. The markup. So how are we going to do this? Well, actually it's not as bad as it seems. The reason is that the boundaries for a markup are always separated by strings already, so when you encounter a component that's not a string, you need to, or when you encounter in the AST like a bold directive, we need to have a way of tracking the current position in the output, so the length of the string up until that point, and then at the end we need to insert an instruction to actually count the length of the string to that point, and then aggregate that. So yes, actual representation and evaluation of the inline stuff, I guess, is going to be interesting, to say the least. But for now, I think I want to focus on the block parts because those are a bit easier to think about. Yeah. I think I want to actually reverse that. So let's see one is first. Not that the syntax really matters all that much. Yeah. Actually, okay. Yeah, I'm going to focus on blocks for now. Alright, so what do we need to do for that? For now, we just ignore everything by default. And then we, for instance, come across the block quote. Then we, well, what do we do on that? Traverse. We output a source line, so emit source was it already source just called that? I don't remember. Yeah, it was. Okay. What is happening? Yeah, let's just keep it simple for now. And otherwise, things proceed as normal. So we do that in the before. What else do we have for things? So if we encounter an instruction, then we need to put that into an evaluation kind of thingy. If we encounter a choice, what else do we have? Emotes. Okay. Jumps. Components. Jump. That is a thing, right? Yes. Yeah. Or let's just call it jump, I guess. Now the reason we don't want to do that immediately is well, we can't know ahead of time which line is going to correspond to an output. So we need to somehow do that in a second pass later. So I guess, how do we associate that information? Because we also don't know right now which line corresponds to which component. So let's actually, when we emit, we want to both output the source from and the component we associate it with, so that we can resolve labels later. So that will be that. Then once we go over it again, we can read out the jump target, which is going to be a component instance, and then from the table of gathered line numbers, or I guess instruction indexes to component things, or component things to instruction indexes, we can insert the proper location. So that'll be a post-processing task, I think, or I guess a post-pass. Okay, so we have the predicate, conditional, components, conditional. Yeah. What else do we have? This is an inline thingy. This is an inline thingy. Inline instructions. Instructions. Emote is inline. Okay, so all of those are inline. We'll worry about that later. Okay, so when we have a conditional, we want to emit a choose, which is actually a bit of a problem here, because the conditional component has no way of knowing what the label is going to be. Do we need a label? That will be the easiest part, just getting rid of the label. Or, not the easiest part, would make things much easier. Yeah. Yeah. No, wait, the conditional isn't to choose. Whoops. Yeah, that's the... I'm mixing things up real bad. That's the unordered list. That's the choose. Conditional is something else entirely. Conditional is basically a cond. How do we do that though? Because it's, again, structured so we can't emit it in one go. Methinks doing it like this is also a bad idea to begin with. The way we could be handled is if we construct new output things to put inside the cond. So interesting. Okay. What did I call things? Clauses, right? So we create a new assembly. Okay. Yeah, I guess that would work, but I don't really like it very much. Yeah. So I think I'm going to make the STE based on, you know, classes, because classes are great. Or the assembly, I guess. Instruction. And every instruction is associated with a component. And a position. Okay. What? Ah, fucking position. Index, I guess. So we have a source instruction, which has a source. We have a jump instruction. Clauses. Okay. Okay, so instead of doing that, we would emit source. Okay, and here again. That, and then here we would have right. And so again, the indexes are in the beginning, they're 0 or not set, unbound, and they're gonna get fixed up in a later pass, and jump targets are gonna get fixed up in a pass after that. Though actually, the index should be predictable within an assembly. So yes. Actually, let's change emit into, or let's see. Let's make def class assembly. We're gonna fill it in later. We're gonna emit instruction. Assembly, we're gonna fill that in later as well. And we're gonna have a defun emit. And this is gonna take let's see, assembly component type, and where we can just, yeah, that's gonna be the same as emitting. There we go. Or when you emit something into the assembly, it could just set the index, which I think would be a bit better, maybe. Yeah, let's just do that. Set index and instruction. Push extend. And that's gonna be that, and we're gonna have a index. Actually, the next index is always the current length of the instruction list. Yes. Okay, so never mind, I don't need that. We'll keep it in anyway. Length. There we go. And we're gonna need there we go. Okay. Good. So now we can change this, or actually keep it. Yeah, that's fine. Yeah. Good. Okay. And there we go. And then we're gonna have another function that can actually evaluate these instructions. Right, but right now we're worried about compiling, not evaluating. Or, well, you know, kind of always worried about both, but we'll take what we can get. Okay, so we have a choice. Then we're gonna do a similar thing to the conditional loop for item components. What was the unordered list? Was a block component list? Oh, it's just a parent. Okay. Now here, this is actually slightly more interesting. Actually for both, we can't do it like this with the index. So we do need a separate index because we need to start off at a different index. Or, This actually... Let me think. No, this is not gonna work the way it is right now. Right. So before I start on this, let me rethink this. So we're gonna need to do what I said before, which is insert additional kinds of, I guess, just tags or no OPs that can be marked, or hold on. When you have a conditional, at the end of the conditional it needs to jump to the end of the conditional. So we need to emit a no OP, I guess, just so we can have a label. Yeah, okay. Oh, fuck. Okay. And I don't think I want to call it a component actually, because yeah, that's not good. We need to call it a do I need to call it anything at all? I'm getting woefully confused about things. Guess I'll call it a label instead. And these labels will be compared by EQ. Fucking Emacs. Sometimes selection just stops working for no reason. Right, label. So if there is no label, I guess we can always assign a default label. Label. Okay, so we're gonna make a no P. It's not, No, actually, yeah, okay, no, this is fine. Canopy, and then don't need an inner assembly at all. We walk the thing, and then at the end we emit a jump. With the target to label of the end. Or actually we could just make the thing itself the label. Don't really need you know, additional symbols to identify it, since we always have a reference to it. Yeah, that makes more sense to me. So let's remove that. Third. Unless it's not. Hooray, circular things. Mm-hmm. Compass. Okay. And then at the end we emit the end, which just does nothing. Okay, so I think this should work. At least the way I imagine it should work. We can test it actually. Maybe. Package component does not exist. Ah, god damn it. How many times? Okay. Please. One warning. Worst. Oh, right. Okay, so let's parse something more simple. We want to have a conditional in there, so let's do that. A very simple thing. Okay, and now we walk. Should go. Okay. We should call this. Okay. Okay, so the conditional followed by no OP and a source. That ain't right. Huh. 0. So what's happening? let's trace walk. Also, let me make a shorthand for parsing things. Okay, walk, parse, make instance assembly. Okay, walk of the root. Unit component. Paragraph. What? So the parse result wasn't even correct. Why? That's confusing. What? Okay. Yeah, why did that happen? That's weird. That didn't happen in the previous tests. Huh. Okay. What if it's like this? Still the same. Oh, because the paragraph ends. That's odd. Huh? Why does it end? Why does the paragraph end? I wonder. Huh. Well, in any case, let's see what that is. Let's define some convenience things, which is around thing assembly. Always return the assembly. And also that's too many parents. Think. Popular typo. And now I need to real quick. What? What do you mean? Oh. Oh. And Pulse Audio has decided to give me shit. Now my headphones are noisy at all times. No instructions at all this time. Oh, right, because we walked nonsense. Ah, fuck. Jump. Conditional. No OP. What? Oh boy, things are going downhill fast. Trace walk. Okay.
Oh no!
Yeah. Okay, we go to roots, we go to paragraph. And again this, why is it parsing things wrong? What is this? No, now it's... Where's this bar coming from? What the fuck? I don't understand. Something is real wacky. Oh boy. Okay, so this doesn't do shit, and then it walks into the conditional, right, and it goes into A. Okay, so what does it do in a conditional? Oh, we don't actually, right, never mind, I think it's fine, probably? So what does it do? A jump and a conditional and a no OP. Where does the jump come from? The first one in any case? Oh right, that's the end of the... Huh? Oh, that's not gonna work like this, huh, is it? Yeah. So we need to do this first. And then modify it later. Emit conditional. Put that into the assembly, then create the clauses, and then instead of... And then emit the end. Okay. Okay, conditional and a jump and a no OP, and a jump should go to the no OP. Okay. Map. Just, I guess. Yeah, so the labels are the components, the jump itself, and yeah, okay. And I can't map the thing, but second. And that should be the NOP. Okay, good. Alright, so that should be proper formatting of the walk. Ah, this noise is really annoying me. It's really, really annoying me. Yeah, it's... So that should be very similar for the choice thing. Actually, it shouldn't be, because for the choice we don't actually want to emit. Do we? Now I'm confused. Oh boy, this is bad. How do we want to do the choice? I need to do the choice differently. I can't do it like this. I need to do it differently because this is too disruptive to the other program flow, or it's too complex of a construct, I guess. So how do we do this differently? Well, I have an idea, which is so whatever. Let me erase this very quick to give another quick example. So my idea for how to do this now is as follows, which is if we have a choice between, like, say, A, B, and C, and A has something, and B has other, and C has nothing, then this choice will be represented as a choose instruction followed by an instruction for how do we want to do this? My idea right now is to unroll all the choices into standard instructions and then have an instruction that says like commit choice, which will make the system take the output up to that point to be part of the choice label. So if we have, like, let's make this actually a bit more realistic, or yeah, let me insert a conditional here just to icon type, you know, just to make it useful. So we would have a choose instruction, and then we have a conditional, and that has its, you know, as a predicate A and a jump tag C1, and then C1 is the string something. And then after it has done that, it does a commit choice. And commit choice needs to do, or actually this needs to be A and then something after that. And then it can do the content instructions, which are going to be C2. C2 has, which is going to be, yes, yeah. And then we have, that's not gonna work. Actually, it is if we add the tags in here. So C1, C3, and C3 is B. Commit choice. And then we have C5, C. Actually, right, C6, and then we have the end of the choice, which needs another label. Wait, this is getting more complicated. So this needs a C7, which does nothing but jump to C8 as part of the label, and then C8 needs to be this. And then C9, I guess, is the end of the choice, which is gonna say, actually I can do it differently still. Sorry, I'm getting a bit crazy here. So we don't have this instruction at all. Conditional blah blah blah, and then it does commit choice, and after commit choice it has a jump to the next choice, which is C3. And after B, after commit choice, it has a jump to the next choice, which is C5. And after that, it has a jump to C9. And at C9, we commit, or we choose, which will take all the choices, the associated labels, and the output buffers, and actually return to do this. Yes, that should work. Yes, okay. I think that'll work for the choice. Whew. So we need a... Whoops, not here. Need to choose. Instruction. Yeah, okay. I was rethinking the conditional, but I think I'm fine with the way it is right now. And we need a commit choice instruction, which has a target. Okay. Let's get in here. So we first need a choose instruction. Make instance choose. Sure. And then we need to not emit that, but we also need... No, we don't need an end in this case, because we have to choose. Okay. So... we also need to gather those, so we loop for child across children of the component. And these are all list items. And so now we need to go through the items in reverse order first, because we need to get to the tags that... So we can jump to the next thing, or do we need to do that? Let me think. No, we don't need that at all. That's fine, because we can just use something else for the tag. I keep forgetting that the tag can, the label can be literally anything. So could be an index, or no, an index it couldn't be. Loop for I from 0 below. We need to have thing for child. Let's do that. Or let's do items equals arif items I. Okay. Okay. So now we need to take the first instruction in that. And turn it into a label. So if the choice has any children at all, or then we take the first one, which might not be a good idea. I need to rethink how that actually works at all. Yeah, that's not gonna work well at all, actually. Yeah, I'll need to think about it a bit, but for now, let me conceptually implement it, because we're nearing the end of the stream already. Jesus. Right, so we walk aref 0. Okay, so this is going to produce us the this is going to produce us the internals of the label. So in this case, this part here. Okay. Or in, you know, since it's actually a it's more like this. Where is it? I'm getting confused again. Ugh. So offer B1. This notation is confusing me more than I already am. Okay, so we emit this stuff, which is fine, and at the end we need to say commit choice. So we emit a commit choice. And this is going to point towards the rest of the contents. So the target is going to be the label of, I guess we're gonna call it a item here. Okay, so we do that, and then we emit a jump with the target being the next section. So actually this is not gonna work out as it is. We need to have a label for that. So I need to emit a no OP here. Or yeah, okay, no OP with the label being the item. And then we're going to go to this is gonna ah, Jesus. Okay. No, that's not gonna work because the last one is not going to have an item to jump to. If smaller I length items smaller than -1, then we have a next one, so we can do aref items 1 plus item, and otherwise we just use the component. Okay. That's fine, that should be good. And then after that, we walk all the rest of the children and go with those. I think that should work out. No, actually we need another... Yeah, we need a different target for this. So... let's just use the children array as a label, I guess. Since no P label children. And now we can loop for I from 1 below. And emit the rest. Okay, and at the end, we emit the choose into the assembly. And that should work fine. Okay. Jesus Christ. Let's see if this is gonna work at all. So first I wanna parse this mess and look at the output from that. Okay, so we have a root component unordered list in there. It has 3 items, each of which have a fucked up conditional because the paragraph messes with it. How? Why? Does that happen for... that? I don't understand that at all. Why that's happening. It doesn't happen if it's nested properly. Fuck. Yeah, so the first thing is always a paragraph, which is not very useful, because it's not actually necessarily the same thing. So we might need to actually enforce that the first thing is in a different paragraph from the rest. Like this. Yeah, so we always have a new paragraph. That is so weird. Is it because the match is considered a fail that it tries to... Is that what's happening? No. Don't really have that at all. So weird. So very weird. I'll have to look at that another time because we only have 5 minutes left. So the conditional test is not actually going to work out the way things are right now. But otherwise this is fine. So let's do that and walk it. Error. Unordered list now. It's not a type number. Oh. Dumb. Okay. We have a no OP followed by a conditional. Wait, it picked up on the conditional? How? I guess because it's in the paragraph? Yeah, okay. Followed by a jump. And a no OP and a commit choice. And a jump and a no OP and no OP commit choice. Jump. Okay. Yeah, it's very hard to debug this. Jump. Oh. Good. It's accessing things it shouldn't. For some of those. Which is interesting. I didn't assume that any of these could have no label or instruction. Or no target. I guess some of them don't have a label. No, wait. Yeah. Index is always set, and the label is always set. I do not understand. Quest is that? Jump. Oh, because it's recursive, right. FEQ instruction. Label instruction. I'm gonna do something like that.
I didn't pay attention, but maybe set asterisk print circle asterisk if you haven't already.
Yeah, I know, print circle should help, but I would rather not deal with the print representation of cycles and things. So I'm gonna do this instead. I really wish print objects things were more easily combinable. Also, this looks like trash. Loop. Cross. Okay, so this doesn't show the type info. Whoops, forgot about that. Type T. Okay, so here we go. We have a no OP, which just associates this with our list. And then we have a conditional. Actually, can I match? Yeah, okay. Yeah, we have a conditional. And we have a jump from 2 to 3. Okay, and then we commit the choice. Okay. It's kind of annoying because we don't actually see the strings at the moment. And then we have a jump from 5 to the next unordered list item, and then there's a thingy which should handle the inner stuff, so there's something which we skip. We go to 7, and we immediately commit the choice, and we jump to the next, and skip that. And next is there, commit, jump, skip that, and get there. Okay, I think that should work. Yeah, obviously this is like, garbage. But yes, I think that should work fine. As it is. Okay. Let me just real quick do something that's not good, but I'm going to do it anyway, so we can see it a bit better, and then I'm going to end the stream for today and work on this some more myself. String, assembly, and we're just gonna connector push extend string into the instructions. So let's get this thing again. Block instructions. Okay. So this is an error from the parser. After conditional, which has an A, and then it jumps to 5, and after 5 it commits the choice, so that's the A label. And then it jumps to the next one, and it marks the beginning of the content with that, and it talks about something. And once we skip to that, if there's no PP, commit choice, jump over this, right, marker of the beginning of the block, okay. Okay, yeah, looks good. I think this is working assembly as much as it can be anyway. Alright, so I'm gonna work on this some more by my lonesome self tomorrow. And maybe I'll even get it to a running state, or maybe not. If not, I'll continue working on it on stream. If I do, I'll definitely show it off and work on binding this into the actual system.
Alright, thank you for streaming. This was a productive day again.
Maybe. Perhaps. Alright, anyway, yeah. So, I hope I wasn't too rambling and too unclear on everything, so I hope if you're not, like, already versed in how to write a compiler and everything, then I hope that it still provided some kind of insight. If not, please let me know, and I will be happy to elaborate on things next time. Alright. Thanks everybody and everyone, and hope to see you tomorrow again. Bye bye.